use to annotate your own variants, and it predicts and annotates the functional consequences of your variants. So for example, if you have done your sequencing analysis and you've called your variants from it, and you would like to find out more information about these variants, this is where VEP can come in handy. So you can feed in SNPs, insertions, deletions, copy number variations, and also structural variants into VEP to find out more information about it. So your data input can be in any of these formats. So they could be the variant coordinates. So this is the Ensembl default format. They could be in the VCF format, HGVS, variant IDs, and also SPDY. Once you've input your data, VEP is going to process this data, and it's going to pull information from Ensembl, but also external resources. And then it's going to give you an output, giving you information on the genes and transcripts that your variants have affected, pathogenicity of your variants if available, frequency data, any regulatory and splicing consequences, and also PubMed citations for where these variants have been mentioned. You can use VEP in 3 different ways. So we have web interface, which is what we're going to use today. But then you also have standalone Perl script. So this is a command line option that you can use. It has a lot more options, more flexibility, and it is suitable for large volumes of data. And then you also have the REST API option. So this is a language independent method that you can use, and it's useful when you want to build simple URL-based queries. However, again, it's not suitable for large volumes of data. So what we're going to do is that we have 4 variants over here. These are Atlantic salmon variants on chromosome 12, and we're going to use VEP to find out whether these variants have already been annotated and what genes are affected by these variants. So I'm going to copy the input from here on my slide, and this is also available if you want to go through it on your own. This input is also available in this VEP tab on the training page, and if you expand demo, you can find it just over here. So it's just over here. So this is the data that I'm using. So let's go back to Ensembl. You can find VEP on the blue navigation bar at the top of the page. So I'm going to click on here. And this takes me to the VEP page, and it gives me some information on the different things that that VEP can find for me. And then we have information on the various different interfaces. So web interface, command line tool, and REST API. All of these options also have documentation that you can read on that takes you through on how to use these interfaces. I'm going to choose the web interface. So I'm going to click on Launch Web. And this takes me to the job form. So I already have a job that I ran previously over here, but we can create a new job by clicking on New Job. Or if you haven't created a web job previously, you'll be directly taken to this page. So this is the job form. So the first thing that we're going to do is we're going to select our species. By default, this is set to Homo sapiens, but we can change species by clicking over here. And I'm going to unselect human, and you can either search for the species that you're interested in. So we're interested in Atlantic salmon. So it's just over here, or you can just go through these different tabs over here to look for the species that you would like. So I've selected Atlantic salmon, and the species has become available on the right-hand side. Once I'm happy with my selection, I can simply click on Apply. Okay, the next thing that we're going to do is we're going to name our job. So I'm going to call it Demo Salmon. Next, we're going to input our data. So you can either paste in your data, which is what we're going to do. You can upload a file from your computer. So files do have a limit of 50 MB. But if you create an Ensembl account, I think this limit is increased. And then you can also provide a file URL. So for example, if your file is located in a public directory, for example, an FTP site, I'm going to paste in my data here in this box. And the way that this data is arranged is that we have, excuse me, let me just double check that I've copied. No, I haven't. Okay, I'm just going to copy this one from here. Let's get rid of this. Okay, so I've put in my data over here. So this is in the VCF format. So we have the chromosome number in the first column, then we have the coordinate information, and then we have information on the reference and the alternative alleles. The next thing that we can do is we can further configure our output. So you can choose from different identifiers for genes, transcripts, and variants. So for example, if you want, you can include gene symbol for the gene that your variant might have affected, protein affected, UniProt ID, and then also HGVS. So VEP is also going to report HGVS from coding sequence or protein notation for the variants that we have input. I'm going to select this. So it's also a really nice way to sort of convert the format of your variants. We've provided the variants in the VCF format, and now our output is also going to give us the HGVS format for those variants. The next thing is variance and frequency data. So by default, VEP is going to tell you whether your variants are already known. We can have some additional annotations for your transcripts, proteins, or regulatory annotations if available. And then we also have some conservation predictions over here. And then we also have some filtering options. So you do have the option to pre-filter your results by coding regions, or you can restrict your results. However, I would advise you to not pre-filter your results until you've run your job, just so that you don't lose out on any data. But once you have your output, there is a lot of filtering options available, and I will take you through those. Once we are happy with our VEP input and selection, we can simply click on this green button that says Run. And it's now going to show me this page that my job is set for a run. So it's queued for a run. So it's just over here, this VEP analysis demo, salmon in salmon cellar. The page refreshes itself every 10 seconds, so you don't need to refresh it. We have date and time for when the job was submitted. And then on the right-hand side, we also have option to save this job. To save this job, you will need to create an Ensemble account, and it's completely free to create, and you don't get any correspondence from us. You also have the option to edit your job, share your job with collaborators, so you can share this link with them, or you can also delete your job. Once your job has run, we can click on View Results. And this is the results page. So to start with, we have a summary statistics over here. So it shows us the number of variants that we processed, which was 4, the number of variants filtered out. We didn't filter out anything, novel or existing variants. It will tell us information about the overlapped genes, overlapped transcripts, or if our variant has overlapped any regulatory features. The pie charts show us all consequences or coding consequences, and then underneath we have our results table. So you'll notice that the results table is quite huge. So, and this is because we show you all of the consequences associated with all of the transcripts. So we have the location of our variants in this first column. Then we have the alleles that are used to calculate the consequence for this variant. Then we have the gene symbol and gene stable ID for where the variant has overlapped this gene. We have information on the feature that was overlapped. So in this case, all of these are transcripts. So we have the transcript ID over here, the biotype of the transcript. And then we also have information on which exon this variant falls on. We have information on the HGVS. So as I mentioned, because we selected for HGVS. So we have here HGVS coding sequence name and also HGVS protein sequence name. Then we have information on, if available, cDNA, CDS, protein position, amino acids. So these would be the resulting amino acids. We have information about codons, and then also the strand orientation. So 1 would be forward strand, and this, then if it was -1, that would indicate reverse strand. I mentioned that you always have the option to filter your table after you have run your job. So this is what we're going to do now. So let's say that we would like to filter our table again by the missense consequence. So if I open this drop-down menu, it's going to show me all of the filters that are available. All of these filters are basically the names of your columns of the table. So I'm going to select consequence. Then we can select the logical operator, which could be is, not, matches, less than, greater than. I'm going to leave it on is, and then we're going to define our consequence. So this is going to be missense. So we have our consequence defined over here. So this is our filter. So let's add this filter by clicking on this add button. We'll just give it a bit of time. Okay, so our table has now been filtered to only show us the variants that have the missense consequence. You can always apply further filters to your table. You can also show and hide columns from here, for example. So if I just click on this, there is further information that we can add to this. We can add to this table. So you can always choose that from here, and then we will show you that information if it is available for the specific variants that you have searched for. To get rid of your filter, you can simply click on this X icon over here to remove the filter. You also have the option to download these results. So you can download the entire table. So that would be the original table without any filters as all in VCF, VEP, or text format. You can download the filter table in the same format, so VCF, VEP, and text. And you also have the option to import your variants and genes from this table into Biomart, and we will be talking about Biomart later on today. Okay, so I finished on good time. Let's try the exercises for VEP now. So again, this is available on the training page, and we have 2 exercises here for VEP. So we have some variants identified in Atlantic salmon, and you're asked to find out which genes and transcripts do these variants map to, and if these variants result in a change in the protein encoded by those ensemble genes. And then the next exercise is also on Atlantic salmon. So we have variants here in the VCF format, and you're asked to find out how many variants were analyzed, how many are novel, how many genes and transcripts are affected by these variants. Do any of these variants have different consequences in different transcripts? And can you export the results to a VCF file? So we'll have until our lunch break to do these exercises. So the lunch break is at 12:30 BST, so British Summer Time. So I think that gives us about just under 15 minutes. But if you have any questions, please do let me know.